Guys, welcome back to my math YouTube channel. Today I am here with another example on integration by parts. Guys, for now this is going to be the last example that I'm going to show you guys about this integration by parts method. We have already covered 6 examples. This is going to be number 7, and then we are going to move into some other techniques and some other methods of integration. Okay, so guys, looking at this function, you can see that it's still a product of two functions. One is x to the power n, which is like an algebraic function, and then there's the log function. Again, before we start working on this, we should verify that whether substitution method works for this, and obviously the substitution method is not going to work for it. There's no direct way of evaluating this integral, so one has to use what we call as the integration by parts. So keeping that in mind, guys, let us see which function we have to denote as or consider as f, and which we can consider as g. That's based on this technique right here. We can see that the log takes precedence over the algebraic function, so we are going to take this as my f function and this as my g function. Guys, you can rearrange these. It's because it's a product, but I mean, we can do that. I did it in my other videos, but in this one I'm not going to rearrange because I have already identified this as f and this as g. I'm now just going to use apply the right hand side. So let us go ahead and start applying the right hand side. For the right hand side is just the f function, which is simply ln of x, and then times the integral of x to the power n. So I'm just going to rewrite that, integral of x to the power n dx, and then minus, again I have an integral, I'm just using this right hand side, and then I have to do the f prime. So derivative of ln of x is simply 1 over x. It's the inverse function. So it's going to be 1 over x times, then I have the integral of the g function, which is integral of, I'm just going to write that, x to the n dx. Of course there's a dx outside as well here, so we got to leave it like this. That is step number 1. Let us try and simplify further. So I have ln of x times then integral of x to the power n dx is a simple power rule, right? So it's going to be x to the power n plus 1 divided by n plus 1. That's just a simple power rule. We use that. Then minus, let us see how we can simplify this. Guys, I just have to leave that 1 over x. First we have to do the integral of the inner, in this case, which is the integral of x to the power n dx, which is again using the power rule, which is x to the power n plus 1 divided by n plus 1, and then finally dx. Okay, guys, I have been trying to show you all different types of examples. Again, this is also different, slightly different than any of the other examples that we have seen. So my goal here is to show you as many different types as we can, or I can here, and then you go ahead and do these different types of problems on your own from the textbooks. Now this is simplified. So here let me rearrange a little bit. We like to have the algebraic function before the log function, so I'm just going to rearrange a little bit. So it's x to the power n plus 1 divided by n plus 1, and then times there's of course this ln of x, got to write that as well, ln of x, and keep in mind they are multiplied. Then minus, let us try to simplify this side. So guys, before we simplify this side, keep in mind there's an n plus 1 in the denominator, and that's like a constant. So what do we do with the constants? We take them outside the integral. So I can just already take that outside, so it's 1 over n plus 1, and then integral, it would be x to the power n plus 1 over x dx. And now we have to just simplify or do the integral for this function, which is not going to be so difficult. Why? Because guys, you can think of this as x to the power 1, right? So this is like, you can just use a simple rules of exponents, which is also called as the quotient rule. So using the quotient rule, guys, this can be simplified. So let us simplify it right here on the side. So this guy is x to the n plus 1 divided by x to the power 1. Using one of the basic properties of simplifying exponents, which is also called the quotient rule, what we do is, when we are dividing and you have the same bases, we are dividing two exponents with the same base, and if you want to convert it into one term, it is just simply you have to subtract the exponent. So which means you have to subtract n plus 1 minus 1. So it's equivalent to x to the power n plus 1 minus 1, but positive 1 and negative 1 crosses out. It's just x to the power n. So guys, this whole term finally condenses to, or is equivalent to, just x to the power n, just by using the simple property of exponents. Guys, this guy is not going to change, so I'm just going to rewrite this. I think we'll have enough space to kind of squeeze this. ln of x, that is done. So let's make sure we don't confuse ourselves. And then minus, guys, this guy, not too complicated, there's 1 over n plus 1 already. And then we just have to write the integral of x to the power n. We know the integral of x to the power n is simply using the basic power rule for integrals. So it's x to the power n plus 1 divided by n plus 1, right? And then of course there's a plus c, and if we simplify all this, guys, this first term is not going to change, so it's the final answer is going to look something like this. X to the power n plus 1 divided by n plus 1. There is an ln of x, and then there's a minus. Okay, guys, here I have an n plus 1 downstairs and n plus 1. So n plus 1 times n plus 1, I can write simply n plus 1 whole square. Of course, I still have x to the power n plus 1, so I can basically write it right here, x to the power n plus 1. Why? Because this times 1 is x to the power n plus 1, and then there's a plus c. Guys, this is the final solution or final integral of this function, which just looking at this, it seems like almost impossible to use any direct method, or even using the substitution method, we won't be able to integrate it. But we have this nice integration by parts formula, so we use that. We take the help from this, where we figure out which to use as f and which to use as g, and then we do all the steps, and finally we have the value for the integral. So guys, this is number 7. I'm going to stop here for the integration by parts method. Again, if you have any other questions from integration by parts, feel free to reach out to me, and I'll be happy to actually either do it up here or give you some hints so that you can probably finish it on your own. Okay, so guys, take care. I will see you next time.